Hey everyone, it's that math magician, and on this video we're going to take a look at geometric sequences, and we're going to determine how to find the recursive equation for a geometric sequence. Now, the recursive equation in an arithmetic sequence and a geometric sequence, they're similar. If you remember from our recursive equation in an arithmetic sequence video, we talked about how if I'm trying to find a term, I have to know the term before it to help us. Remember, we take that term before, we add the common difference to that. That same idea is going to happen with geometric sequences, but instead of using our common difference, we have to use our common ratio. So let's go ahead and write down a sequence, a geometric one, that we can use to help us determine the recursive equation. So let's go ahead and look at the geometric sequence of 2, 8, 32, and 128. Let's put 3 dots at the end of that to help us understand that that sequence does go on forever. Now, just like with an arithmetic sequence, we needed to know the common difference and the zero term. Same idea for a geometric sequence. We need to know the common ratio and the zero term. Remember, the common ratio is how are we moving from one term to the next. In a geometric sequence, that's by multiplying. So some of you might be able to see what that is right now. Some of you might not be able to. But to help you with that, remember, we do have a little way of finding that. R stands for common ratio. In order to find our common ratio, remember, you can select any number from the sequence. I'll go ahead and select the 32. We want to divide that by the term before it. So if I'm looking at 32, I want that term right before the 32, which would be my 8. So I take 32, I divide it by 8. We determine that that common ratio is 4. That means as I move through this sequence, I am multiplying by 4 every time to get the new term. That's great for us. We see that this is our first term, our second term, our third term, and our fourth term. Next on our list is we need the zero term. We need that term right before the 2 so it can help us determine that recursive equation. Now, to find t of 0, the hint I gave in the previous video was to take our first term. We know our first term is 2. If you're ever trying to find out your zero term, take the first term, divide it by your common ratio. So we take 2, we divide it by 4, and we end up realizing that our zero term here is 1/2 or 0.5. So perfect. We have our common ratio and our zero term. Let's go ahead now and write out what our recursive equation would be. Now, just like with the arithmetic sequence, the recursive equation is also going to start off with t of n plus 1. Remember that n plus 1 just refers to the next term. You're looking at n plus 1 is the next term in your sequence. So we take t of n plus 1. It equals t of n. We have to have t of n in there, right? I'm looking at this new term. We have to take the term before it. What was the old term? In a geometric sequence, we take the old term and we multiply it by our common ratio. So for our generic formula here for the recursive equation, what goes in front of Tn is R. We need to take our old term, multiply it by our common ratio. That is the formula for a recursive equation for a geometric sequence. It is t of n plus 1 equals r times t of n. Again, you have a term that you know, multiply it by the common ratio, that will equal the next term in your sequence. Now for us, again, we do know what our common ratio is. Our common ratio here is 4. So for us, our recursive equation is 4 times t of n. Now, just like our arithmetic sequence, we need to tell the reader where we're starting at. Because right now, all I know from this equation is that we are multiplying by 4 every single time, but I don't know where this sequence starts. That's where our 0 term comes into effect. We need to make sure we write down so the reader knows that this sequence starts t of 0 at 1/2. So here's how we use that recursive equation. I know what t of 0 is. The next on my list is to find t of 1. To find t of 1, that is equal to our common ratio times t of n. Remember, t of n and n plus 1, that is just one less. So if I'm looking at the first term, I need to take our 0 term, the term that is one less than the first term. So if I'm trying to find that first term, let's take the 0 term right before it. We know that our 0 term here, it'll end up being 4 times 1/2. Well, 4 times 1/2, that ends up equaling 2. So by using our recursive equation, we had our starting point. We use that starting point in our recursive equation. We have 4 times the 0 term. We end up that our first term is 2. We can repeat this process again. Let's say I wanted to find the 5th term of this sequence, right? We don't see that 5th term here, but I want to find that 5th term. So it says to take t of 5 equals our common ratio, which is 4, times the term before, right? I'm looking at the 5th term, that term before the 5th term. The term before our 5th term, that's our 4th term, t of 4. Well, we know what t of 4 equals. We have 4 times t of 4. T of 4 ends up equaling 128. So we know that our 5th term here will equal 4 times 128. 4 times 128 ends up equaling 512. So we see that the next term on that sequence there for our 5th term is 512. Again, recursive equations, they depend on the term before it. You can't find the new term unless you know the term before it. All right, guys, it's that Math Magician, and I'll see you on the next video.